We've got an epic binomial expansion question here. We're asked to show the coefficient of x to the minus 12 in this expansion is minus 15 and to calculate the coefficient of x squared. So the nice thing is that we can kind of check our answer along the way because we should get minus 15. If we do, we can be pretty confident that what we're doing is correct. So I decided in this question I need to do the expansion of the whole thing. I mean, you could, in theory, think about the terms to cross multiply. I just think it's quite easy to miss them. So that's what I'm going to do. I'm going to start out actually with Pascal's triangle because rather than working out all the binomial coefficients by using factorials, actually we can just use Pascal's triangle. It works really well for small numbers such as 5 and 6. So this is the expansion of 1 plus x squared. We get, or a plus x, a plus b all squared. We'd get 1, 2, and 1 as the coefficients. Okay, we just keep going. So that is for 4, and then this one here is going to be for 5. Right, so that means x to the 4 minus 1 over x squared to the 5 is going to be x to the 4 all to the power 5. That's that one there, plus 5 lots of x to the 4 to the 4 multiplied by minus 1 over x squared plus 10 x to the 4 to the 3. Okay, we'll just proceed in this kind of way. Just be really careful with these negatives and everything. X to the 4 squared. Okay, and then let's simplify. X to 20, here I'm going to get minus 5. 16 minus 2 gives 14. It alternates whether we're plusing or minusing. 12 divided by 4, we're going to get 8. So we're actually going down in powers of 6 every time. Sorry, 10x to the 8 minus 10x squared plus 5 is going to be x to the minus 4 minus x to the minus 10. Okay, there's our expansion. Brilliant. Now for x minus 1 of x all to the 6, I just need an extra row in Pascal's triangle. 1, 6, 15, 20, 15, 6, 1. Okay, there's an extra term, but actually this one's easier to deal with because I don't have an x to the 4 or x 1 over x squared in there. So x to the 6 is 6x to the 5 times minus 1 over x. That will simplify to x to the 6 minus 6x to the 4 plus 15x squared. We're going down in powers of 2 each time here. Just be really careful with negatives. So minus 20 plus 15x to the minus 2 minus 6x to the minus 4 plus x to the minus 6. And I'm ready to put them all together now. So therefore, x to the 4 minus 1 over x squared to the 5 multiplied by x minus 1 over x to the 6 is going to equal this multiplied by this purple one. So first, let's look for the x to the minus 12 terms. And to cross multiply. Now we could start with the top bracket. I will do that. So x to the 20, I'd have to times it by x to the minus 32. You can see it's just way too big. And as we work our way down, they're still too big. Like even x squared times x to the minus 6 gives x to the minus 4. So the only place where it works is, well, we get a term, is by multiplying these two together. Minus x to the minus 10 times 15x to the minus 2 equals minus 15x to the minus 12. So the coefficient of x to the minus 12 is minus 15. Then we're asked for the x squared terms of the coefficient. Okay, again, x to the 20 isn't going to work, x to the 14, no. But x to the 8 and x to the minus 6 will work out. And I'll get 10x to the 8 multiplied by x to the minus 6. And then how else am I going to get it? I'm going to get one from here. So it will become plus 10x squared times 20 because there's a double negative. I've just eliminated them straight away. And then finally, x to the 6 times x to the minus 4 will also work. This gives 10x squared plus 200 x squared plus 5x squared, which is 215 x squared. So the coefficient of x squared is 215. Okay, well done if you managed to get that one. Now, hence or otherwise, calculate the coefficients of x to the 4 and x to the 38 in this expansion. The hence is a bit of a clue here. Of course, otherwise means we could expand the whole thing, but this is 11, and this has got 3 terms in it. It just looks horrendous. So let's play around with it and try and see if we can, use the original result in any way. And what I decided to do is let's just see what happens when we multiply a pair of brackets here. So I'm going to get x to the 6 plus x to the 4 plus x squared from these. Then minus x to the 4, and you can see something happening because all of these are going to, this is going to be minus x squared minus 1. These cancel, I actually just get x to the 6 minus 1. This is brilliant because what I can do is I can take my expression and write it as x squared minus 1 to the 6 multiplied by x squared minus 1 to the 5 multiplied by x to the 4 plus x squared plus 1 to the 5. And this thing here is simply going to become x to the 6 minus 1 all to the 5. This is immediately much nicer because we're down to just a power of 6, a power of 5. Okay, this is a power of 6 in x, but there's not 3 terms anymore. You could expand that like we did in the first part, but let's keep going because there's still a hence, and we can see there's a power of 6 here and a power of 5 here, very similar to our starting one. So could I somehow rewrite this as this? Well, I could factorize an x out. So it would be x times x minus 1 over x, and all of this would be raised to the power of 6. And then I'm managing to get this expression. And then I'm going to times by, okay, I want x to the 4, so maybe I could factorize an x squared out of the second one. So x squared, and then I'll be left with x. I know I've got them the wrong way around. I'll sort that out in a minute. But x to the 4 minus 1 over x squared, and then all of this is raised to the power of 5. So that means I get x to the 10 from here, and I get x to the 6 from here. I'm going to get x to the 16. And I'll be multiplying by x to the 4 minus 1 over x squared times by x minus 1 over x to the 6. I have exactly the same expression, except I am multiplying it by x to the 16. Amazing. We're actually at the answer with very little further work. So the coefficient of x to the minus 12 in the original expression was equal to minus 15. This minus 15 is the coefficient of x to the 4 in the new expression, because I'm basically finding this and then I'm timesing it by x to the 16. So let me just write down coefficient x to the 4 equals minus 15. Now in the earlier part, we found out the coefficient of x squared. And that would, if I times that by x to the 16, I'm actually going to get x to the 18. So I'm going to have to do a little bit more. It's going to, if I do 38 minus 16, then in fact, I need the coefficient of x to the 22. All right, so we just need to find this out. We've already got, here we go, this cross multiplying expression. So x to the 22 is going to come from there. And actually, that is it. This 14 doesn't go with anything. The highest power is 6. We get x to 20. And then 8 is going to be even less. So coefficient of x to 22 is 15 in original. Therefore, coefficient of x to the 38, remember, because it's the same expression. Just want to remind you, same expression, but we're times them by x to the 16. That is it. In new. A really nice method for this last one. It just looks like absolutely horrible, but turns out to relate to this. And of course, that was quite involved doing that, all that original stuff. Be really careful with the negatives. But yeah, overall, really nice question. Well done.